So in our previous class, we have completed the overtaking side distance, and we have solved some numericals on overtaking side distance. So in this class, we have started a new chapter, that is basic of design of horizontal alignment. So basically in this unit, you will go through different horizontal alignment like your super elevation, extra widening, etc. So let us first discuss about what are some basic portions of that horizontal alignment. So in the horizontal alignments, what are the different elements which you need to consider whenever designing some horizontal alignments? So these considerations are design speed, that is the speed of the vehicle, horizontal curve, if there is any curve, super elevation, types and length of the transition curve, widening of the pavement of the curves, and setback distance. So these are the things which we will discuss in this horizontal alignment chapter. So first one is design speed. Okay. So basically, as we have already discussed in our previous chapter, design speed is a main important thing while you design for the any of the geometric features of the highway. Okay. Now, in the design speed, whenever adequate data are not available, that what should be the design speed of a particular area, in that case, you have to provide the design speed value as 98 percentiles of the speed. Okay, now if there are some data for the design speed, in that case, you can directly refer to the data. So what are the different data for the design speed for different type of terrain? So these are the terrain classification. Terrain classifications, plain means which is flat area. Okay. Rolling means which is slightly hilly area. Mountainous means which is a mountainous range, and steep means which is more steeper. Okay, totally hilly area like that. So these are the classification of the terrain. Now, how this classification of the terrain has conducted based on the cross slope of the country. Cross slope of the country means if you cross sections a particular area, suppose your state, suppose particular Assam state is there, if you cross section this state, in that case, if you find that your cross slope of the country means average uh, elevation in each and every horizontal movement, if it is within 0 to 10%, in that case this type of land uh, would be called as plain terrain. Okay, now if that cross slope is in between 10 to 25%, it is called as rolling terrain. If that cross slope is 25 to 60%, in that case it is called mountainous terrain. And if it is greater than 60, in that case it is called steep terrain. Now, these are the design speed values based on that different types of terrain. So, for the national and state highways, if it is ruling terrain, so in that case, if it is plain terrain, for ruling and minimum, ruling means what should be the maximum and what should be the minimum. So your that speed value is 180. So likewise, all the speed are in kilometer per hour. All the speed values for different type of terrain and for different type of roads are provided over here. So based on this design speed, you have to calculate all the elements of that horizontal alignment as well as some vertical alignments. So basically, these are the design speed which will govern the overall geometric design of the highway. So next thing is horizontal curve. Okay, so whenever you provide that horizontal curve, so horizontal curves are provided when we need to change the direction. When we need to change the direction, in that case we need to provide that horizontal curve. Suppose that is a particular road, and we need to go in this direction. Suppose that is another road, so you need one horizontal curve over there to swiftly move from one direction to another direction. So basically that is the function of the horizontal curve, and this is the way, this is the reason why we provide horizontal curve. Now, in the horizontal curve is a curve in plan to provide change in direction to the central line of the road. Now, when a vehicle traverses in a horizontal curve, suppose one horizontal curve is there. Now, when a vehicle is moving, suppose one vehicle is moving in that horizontal curve, in that case, centrifugal force would be acting outward. Okay, centrifugal force would be acting outward, and the centrifugal force value P would be equal to P V W V square by G R. So that is your centrifugal force, and P by W, that ratio P by W equal to G square by GR, and it is called centrifugal ratio. So this is the centrifugal force P equal to W V square by GR, where W is weight of the vehicle, V is speed of the vehicle in meter per second, G is gravitational acceleration, and R is radius of the horizontal curve. Now this P by W, as we discussed, P by W is known as the centrifugal ratio or impact factor. Now this centrifugal ratio is equal to V square by GR. So from that equation you got P equal to W V square by GR. So your P by W equal to V square by GR, and P by W is called centrifugal ratio or impact. Now, when a vehicle moves in a horizontal curve, uh, actually there are two types of actions or two types of uh, phenomenon which can happen in a horizontal curve. Okay, so what are these phenomenon? One is overturning effect and another one is transverse skidding effect. What is overturning effect? That is tendency of the vehicle to overturn. That is overturning effect. And transverse skidding effect, that is the tendency of the vehicle to skid outward directions. Okay, skid in the outward direction, that is in the direction of the action of the centrifugal force. So these are the two effects, overturning effect and transverse skidding effect. Now the question is, when this overturning effect will happen, or when this transverse skidding effect will happen. Okay, what is the limiting case when these two types of phenomenon will occur? Okay, so first, if you go for the overturning effect, so this is the cross section of a vehicle, and suppose W is the weight of the vehicle. If W is the weight of the vehicle which is acting in the downward direction, in that case, if A and B are two support tires, then that W force will be equally distributed among these two tires, that is here A and tire B. So here your load would be, or reaction would be, W by 2, and here it would be W by 2. Okay, now if the total this total distance, okay, total distance is B among the central line of the two tires. In that case, that half portion would be basically your V by 2. So weight of the vehicle would be act downward through the center of gravity, and therefore from here to here this distance would be your V by 2. Okay, and the action that is the your centrifugal force that will also be acting through the CZ, center of gravity, in the outward direction. Okay, in the outward direction. And suppose the height of that CZ is h, height of the CZ is h. Now if we take moment about point B, okay, about point B, or about RB, about point B, in that case you can write that P into H, P into H equal to W into B by 2. Okay, that is the W, and it is acting at a distance of B by 2, W B by 2. So what is your centrifugal acceleration? That is P by W equal to B by QH. Okay, so it indicates that when your centrifugal ratio centrifugal ratio is, so it indicates that when your centrifugal ratio is equal to B by 2H, in that case there is a tendency of the vehicle to overturn. So this phenomenon is called overturning effect, and this overturning effect basically happens because of that a centrifugal force which is acting in the outward direction. Now another thing is there that is called transverse skidding effect. Transverse skidding effect means the vehicle will skid in the outward direction, in the direction of the action of the centrifugal force. So suppose that is your uh, vehicle is situated over there. So because of the transverse skidding effect, it will be acting in the direction. This vehicle will just skidding over here. Okay, so that is called transverse skidding effect. Now that is also occurred because of the centrifugal force which acting in the outward direction. Now when it does happen, so the thing happened for the transverse skidding effect. So here transverse skidding effect will be nullified by the frictional force. So if the frictional force generated over there is more than the centrifugal force, in that case there will be no transverse skidding. Okay. Now if the frictional force generated over there is lesser than the centrifugal force, in that case there will be transverse skidding effect. So basically that is the thing we know. Now how to prove that thing? Suppose this is your vehicle. Now this, if the vehicle is moving in through a horizontal curve, in that case if that is the CZ, center of gravity, and if it is the outer wheel, then the pressure in the outer wheel would be higher than the pressure from the inner wheel, because of the centrifugal force, because that vehicle is pulling in the outward direction, therefore pressure over here would be higher. Now, if W is weight of the vehicle, okay, and through this portion, if suppose in the opposite direction your frictional force is acting, so basically this is the direction of the centrifugal force. So that would be the direction of the friction, coefficient of the friction. Now, if Ra and Rb are the two support conditions, in that case, your F coefficient frictional force over here would be F into Ra, and here your frictional force would be F into Rb. What is F? F is the coefficient of friction. Ra and Rb are the reaction force at A and B. Okay, F equal to Ra plus Rb. Now another thing, if you add up this Ra and Rb, so you can easily find out that Ra plus Rb is nothing but weight of the vehicle. So you can directly write F into Ra plus Rb equal to F into W. So your P by W would be P by W is basically equal to F. So when your centrifugal ratio is equal to frictional coefficient or more than that, in that case there is a chances of transverse skidding of the vehicle. Now the thing is, if F is less than B by 2H, if F is less than B by 2H, and if F is less than B by 2H, the vehicle would skid and not overturn. It will not overturn. Suppose your coefficient of friction value is lesser than your centrifugal ratio, but F is less than B by 2H. In that case, that vehicle would skid, but it will not overturn. If B by 2H is lower than F, the vehicle would overturn on the outer side before skidding. So the transverse skidding effect will depend on the F, whether F is higher or lower. Now the thing is how to nullify the transverse skidding effect. Okay, now if you go for the definition, let us discuss about these things. If you go for the definition of the centrifugal acceleration, in that case, that centrifugal acceleration or impact is nothing but P by W equal to V square GR. Okay, so one way to nullify this effect is reduce the V or reduce the speed of the vehicle or increase the radius of the curve, radius of the horizontal curve. Now, if that portion or area is limited and you cannot go beyond from a particular R value, in that case, what to be done? In that case, you have to reduce the speed. Okay. Now the thing is there any other way so that we need not to reduce the speed and as well as we can provide safety to that particular section of that horizontal graph? Is there any other way? Yes, there is one way. That way is to provide super elevation in the outer edge. So how the super elevation will affect? Now the thing is, without that super elevation, what will happen? Suppose that is a plain road and that is a vehicle. If centrifugal force is acting in that direction, in that case, the only thing will resist the centrifugal force is only the frictional force. Okay. Now the thing is, we can increase the frictional force. So how to increase the frictional force? So either we can change the uh, uh, texture of the texture of the road material or texture of that vehicle tire, but it is also not so feasible. So in that case, what we can do, that we can provide some slope in the outer direction. Okay. So if you provide some slope, let me draw this with that, it will be easy. So that is the outer direction. We can draw some slope like that. Okay. In that case, if the vehicle is there and centrifugal force is acting in this direction, but here that frictional force would be increased by introducing this curve over there. Okay. So basically this portion, that the elevation of the outer layer of the pavement with respect to inner layer, so as to nullify the effect of the centrifugal force. So basically that is your super elevation. Okay. So super elevation is nothing but the angle formed over here. So basically that is your super elevation. So for this reason, to nullify the effect of overturning effect and transverse skidding effect, we need to provide super elevation. Is it clear? So here the coefficient of the friction value, will be considered as maximum coefficient of the friction value would be considered as 0.15. 0.15. So that is the maximum value of the coefficient of the friction for this case. For both the cases, basically for both the cases, transverse skidding effect and for overturning effect, uh, that coefficient of the friction values is fixed as 0.15. But for the overturning effect, basically there frictional resistance will not act. Why it will not act? Because coefficient of the friction value will only be applicable when that will skid or that will go like this way. Okay, that will go like this way. But in the overturning effect, what will happen? Based on this outer wheel, the total vehicle would be just overturned. Okay, the total vehicle would be overturned. So in that case, you do not need to consider that coefficient of friction value. But for all the cases, lateral coefficient of the friction value is considered as maximum value is considered as 0.15, and for the longitudinal coefficient of friction, that is considered as 0.35 to 0.40, depending on the speed of the vehicle. Okay, you can leave the class.